Hello, everyone. Today we're going to talk about probability or the introduction to probability. So what we're looking at is the understanding of the concept of teaching probability within the primary school level. But however, this is all about understanding probability and the introduction to it. So probability is the numerical measure of the likelihood that an event will occur. So for example, what is the likelihood that tomorrow it will be raining? So in order for us to know that whether tomorrow it will be raining or not, we look at the factors that influence the rain. And with those factors, that's the one that will determine the likelihood of it raining tomorrow. Which means if there are clouds today, for example, if the temperature is very high and there is no wind, then we know that the chances are more compared to when it is windy and also when the temperature is very low. So there are different factors that influence. So when you talk about probability, we talk about the likelihood based on the factors that influence that particular aspect. So in order for us to look at probability, it is done, talk about the probability of an event, which is P and E inside the brackets, which is pronounced as probability of an event or probability of E. So in a simple random experiment, if there is some favorable outcomes out of the total number of possible outcomes, then the probability of an event can be determined by means of using a formula. So if you look at the probability is equal to the number of favorable outcome divided by the number of possible outcome. So basically, favorable outcome is the outcome that I want. Possible outcomes are all the outcomes that there is. So for example, if we're talking about what is the probability of me getting a 5 when I roll a dice. So a favorable outcome is getting at 5, right? And possible outcomes, it's all 1, 2, 3, 4, 5, 6. So all in all, this will be 1 because there's only 1 5 out of all 6. Okay. Then we talk about the sample space. A sample space is the total number of the possible outcomes. Okay, and that is called the sample space. So in a sense that if you look at tossing a coin, when you toss a coin, you can only get a head and a tail, right? So as a result, head and tail is my sample space. So let us suppose we are flipping 3 fair coins together, and then the question says, find the sample space and the favorable outcome for at least 2 heads. So if you look at what I have there, this is the sample space. These are all the outcomes I can get if I throw down 3 coins. I can get head, 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 tail, head, tail, tail, or all of them being tail, and so on. But then the question says, find the sample space and find the favorable outcome for at least 2 heads. Okay, so if you're talking about the 2 heads, here there's 2, and here there's 2, and then here there's 2 as well, and here there's 2, right? So all in all, I've got 4/8 or 4/8, right? Which is the same as 1/2 or 1/2. And that's your probability. Okay. And that's the fact that here we're looking at 2 heads and all of them. And all in all, I have 1, 2, 3, 4, 5, 6, 7, 8. And then we just take those 4. Okay. So find the sample space of rolling a dice. A sample space, I said, it's all the outcomes that there is within the event. So in this case, 1, 2, 3, 4, 5, 6 will be my sample space when the dice is rolled, because why? In all, I will get 6. Okay. And that makes you understand the concept of understanding the sample space. Now, in terms of calculating the probability, you have the theoretical probability and experimental probability. So theoretical probability is the likelihood of a particular event based on the number of total possible outcomes. So this you will see it, for example, if I'm saying what is theoretical probability in terms of this is where we use the formula or they use the calculations, right? If you conduct an experiment, we then know that what? Because there's only 2 head and tail when you toss a coin, therefore, whatever you get is going to be 50% because it's 1 out of what? Total possible outcome, which is always the 2. Okay. Then you have the experimental probability. So the experimental probability is based on the experiment. So in terms of the coin, let's say I toss the coin 20 times and then I get 11 heads. then the experimental probability of heads will be 11 out of 20, based on the fact that this is the answer that I got from the experiment. However, when the number of trials of an experiment increases, then the experimental probability gets closer to the theoretical probability. So basically, the more time I spin the coin, the more chances of me getting closer to that 0.5, which is the one that we normally get when we do the theoretical probability. Okay, so now let's talk about the different type of events that we have, because these are the ones that normally help us understand the calculations. Okay, so in probability theory, an event is a set of outcomes of an experiment to which probability is assigned. So, for example, if I'm saying the event, what is the probability of me getting a 5 when I roll a dice? So, for me, rolling a dice is what? It's an event, which here is an experiment to which the probability is assigned. I'm assigning the probability of getting a 5, right? Because I'm assigning a probability of getting a 5 on an event that the coin or the dice was rolled. Okay, and that's what we mean by what? The event. So we have different types of events. Number one, we have certain events. Certain events are the ones that they always happen no matter what. For example, what is the probability that it will be Friday tomorrow if today it's Thursday? That is guaranteed. It's going to happen, right? It will be Friday tomorrow, provided today is Thursday. Okay, so that is going to be 1 or 100%. Impossible event is an event whose probability is 0. Okay, so in this case, for example, what is the probability that it will be Saturday tomorrow if today is Thursday, right? That is impossible, because when it's Thursday, it can't be Friday the day after. It can't be Saturday the day after. We still have to have a Saturday. So that is why we say it is impossible. Then 3, we have the mutually exclusive events. These are events that cannot happen at the same time. So, for example, when you toss a coin, you can only get a head or a tail. You can't get a head and a tail at the same time. That is impossible. So we call these mutually exclusive events, because you can't get the 2 events to happen at the same time. Then you have the mutually inclusive events. These are events that can happen at the same time. So, for example, getting a number which is a multiple of 3 and also divisible by 2 when a dice is thrown. So if you look at this, you can see I've got 1, 2, 3, 4, 5, 6. Numbers that are divisible by 3, it's a 6 and a 3. Okay. A number that is divisible by 2. 6 is divisible by 2. Can you see? So I can have a number which is divisible by 2 and also a number which is a multiple of 3. So these 2 things are happening at the same time. Can you see? Because I can get a number that is a multiple of 3 and also divisible by 2. And that is why we call this what? A mutually inclusive, because it's happening at the same time. Okay. So based on the event provided, whether the pair of events are mutually exclusive or mutually inclusive, and provided a justification for your conclusion. Okay, draw a king or an ace from a deck of cards. Drawing a king or an ace from a deck of cards. If you look at deck of cards, there's no chances that a card can be a king and an ace at the same time, right? So as a result, that is what? Mutually exclusive. Because why? This set of events is mutually exclusive, and we can either have an ace or a king, but both cannot be drawn simultaneously. Okay, number 2, on throwing a dice, getting an odd number or a number greater than 3. So if you look at these numbers here, I've got 1, 2, 3, 4, 5, 6. An odd number is 1, 3, and then 6. And then a number greater than 3. We've got 4, 5, 6. So if you look at 6, 6 is 6, okay? What did I do? Oh, I made a mistake. Sorry. Okay. What I'm looking at here is, for example, if you look at this. Okay. So in terms of what I was saying there, you'll see that the odd numbers is 1, 3, and 5. Okay. A number greater than 3 is 4, 5, and 6. So by means of looking at that, you can see from there that what? That 5 is an odd number and also greater than 3. So this can be happening at the same time. And that is why we say this is what? Mutually inclusive. Okay. Then you have complementary events. These are events that are happening in a sense that it's it's a negating of what is happening. So for example, if you look at the question that I have here, out of 6 balls given in a bag, 3 are given to be white. Find the probability of not getting a white ball. So in this case, I'm gonna say what? Probability of not white. And this will be equals to 1 minus probability of white. Okay. 1 minus probability of white. How many whites do we have? We have 3, and then in a bag, right? And then we were told that out of 6, which means we have total of 6. Okay. And then 1, and then you can just use a calculator, but this is the same as 6 over 6, which is the same as 1 minus 3 over 6. And then the answer is 1 over 2. Or you can just say 3 over 6, which is giving us 1 over 2. Okay. Then combined probability of 2 events. This is where we talk about the word or. When you see the word or, then you know that, and this is the word or I'm talking about here, okay? That you're going to be doing the addition, right? However, you need to first check whether it is mutually exclusive or mutually inclusive, because then you need to subtract the combination if it is mutually inclusive, and if it is mutually exclusive, you just add. Okay, so for example, a fair 6-sided die is rolled once. What is the probability of getting a 3 or a 5? If you look at the 3 and the 5, these are mutually exclusive, right? Because why? You can't get a 3 and a 5 at the same time after you roll a die. So a probability of 3 or 5. Okay, so this is the same as probability of 3 plus probability of 5. Okay. How many 3s do we have when you roll the dice? You only have 1 out of 6. And then how many 5s do we have? We have 1 5 out of 6. And then if I add these 2, I'm going to get 2 6, which is the same as 1/3. And that becomes my answer. Okay. Now look at this one here. A first 6-sided die is rolled once. What is the probability of rolling an even number or a number greater than 3? So if you look at this again, I've got 1, 2, 3, 4, 5, 6. And then even number is 2, 4, 6. A number greater than 3, I've got 4, 5, 6. So 4, which means 4 is greater than 3 and it's also even. 6 is greater than 3 and it's also even. So we can have the things that are happening at the same time. So which means this time I'm going to use that other formula, which is different from the first one. So probability of even or greater than 3 is equals to probability of even plus probability of a number greater than 3 minus the combination of the two, probability of even and greater than 3. And this is just the combination. So this is equals to, what is the probability of even? The even number in this case here, we've got how many even numbers? I've got 3 even number out of 6. plus. How many numbers are greater than 3? I've got 3 as well out of 6. How many numbers have the combination of the two? It's only 4 and 6, so it's 2 of them out of 6. And then this is equals to 6. And then 3 plus 3 is 6. 6 minus 2, it's 4, which is 4 6. Okay, and this is the same as what? 2/3. Okay, so when it's mutually inclusive, you use this formula. And then when it's mutually exclusive, you use this formula here. Okay, and that is what happens there. Okay, now let's move on to the multiplication rule. So the multiplication rule, we see it with the word and. This is the one, and when you see the word and, it means that you must multiply. So probability of occurrence of two events or in other probability intersection of two given events is equal to the product obtained by finding the product of the probability of occurrence of both events. So this implies that if A and B are two events given, then the answer will be probability of A multiplied by probability of B. And then I said you see it with the word and. Okay, so if you look at, so this one as well, it is dependent on the two things. Is it a dependent event or independent events? So a dependent event are the one in which the occurrence or the outcome of the first event is affected by the occurrence of the outcome of the next event in line. So basically, for example, for it to be a Saturday today, it is affected by the fact that yesterday was Friday. You see, and as long as it's not Friday, this which means that what? It's not gonna. It's tomorrow is bound to be Saturday. So in this example, if we draw 2 cards from given deck of 52 cards, then the event of getting a heart first and a red queen are dependent. Why? Because why? If I take a heart out and then a red queen, which means what? Because a heart is already red, it means that I've already taken out. So which means when I go back, the total has changed because 1 is no longer in. So there's a decrement. Let's look at this question here. 2 cards have been drawn from the deck of 52 cards without replacing the first one back. Find the probability of getting the first card as king and the second card as queen. Okay, let's look at this. So find the probability of getting the first card as king and the second card as queen. Because of the and, it means that I'm going to multiply. Probability of king and queen. Okay. So in this case, I'm going to multiply. So it's probability of king multiplied by probability of queen. Okay. Which is equals to here. Then as we move on there, okay? And then there's a part here. It says without replacing the first one back. So the first time, how many kings do I have? I've got 4 kings out of how many cards? 52. Multiply by, how many queens do I have? I have 4 queens out of, but because I've already taken the first king out, so now it means that the total changes to now 51. Okay. And then I just move on there to write the answer. Okay. And this makes you understand that it becomes easier for you to do the calculation. Okay. So 4 times 4 there, I'm going to get a 16. And then 52 times 51, I'm going to get 2,652. Then you can simplify that. Okay. Now, let's look at one last one here. In a certain test, 5 out of 20 students scored an A, who chooses 3 students at a random out of 20 students with replacement, right? With replacement. So if I'm taking it back, it means that this is independent. It doesn't affect the second one. So I still use the same formula, probability of A and A. And why is it an and? Because here they said probability of 3 students. Oh, and A again. Okay. And this is equals to probability of A multiplied by probability of A multiplied by probability of A. Okay. Now, because there's a replacement, it's always going to be 5. There's 5 A's out of 20 multiplied by 5A multiplied over 20 and multiplied by 5 out of 20. And this is because of this word with replacement. Okay? And 5 times 5 times 5, we're going to get, I think it's 125. And then we look at 20 times 20 times 20. Okay? So 20 times 20 times 20, which I get 8,000. And then you can just simplify that. Okay. And then that's how you normally work with the calculations together with how you understand the probability. Okay. Thank you, guys.